if we want to compute the noise power at a room temperature at 1 hertz bandwidth, so in this equation put delta F equal to 1, put T is equal to 300 Kelvin, that is the room temperature, and you know the K value of K, and you take logarithm for that, you will get the answer for the noise power as 4 into 10 power minus 21 watts, or in dBm scale it is minus 174 dBm at room temperature. So you can see the noise power is approximately zero, but this noise power will increase if my temperature is more or my bandwidth of the system is going to be very, very large. But even such a small noise, when it is going to pass through an amplifier, this also gets magnified, right? So this is also going to create problems for you. Even it may look very, very small. See, we are doing it only for 1 hertz. But assume if you do the same thing for 1 megahertz, you have to multiply this by 10 power 6. So 10 power minus 21 will become 10 power minus 15. So slowly the noise starts peaking up as the amplifier starts working. Okay, so we cannot ignore this thermal noise considering the value is very, very small. We have done this only for 1 hertz. So it is going to be large when the bandwidth is going to be very, very large. And they say that we theoretically we say that this noise power is going to be constant for a particular bandwidth, right? So they say that even when you take between 1 megahertz and 2 megahertz, what is available noise power, that is going to be same as the noise power between 1 gigahertz and 1.001 gigahertz. You know the upper cutoff frequency minus lower cutoff frequency is your bandwidth, right? So the difference is going to be 1 megahertz. Wherever the difference is 1 megahertz, the noise power is going to be same within that particular interval. Okay. So any doubts so far in this thermal noise, you can ask any doubts if you have. Are things clear? See, I did not take the other topics because they are very advanced. So I felt comfortable taking the noise as the first topic because at least you will have some understanding of noise, and this is going to make the understanding also very, very simple. Any doubts or any queries you have, please don't hesitate to unmute and ask even during the class also. I hope things are fine so far.
Yes, sir. Fine.
Yes, sir.
Yes, sir.
Okay, okay, thank you.